you, Dylan, and good afternoon, everyone. It's great to be here to close out the afternoon session on our final day at HAProxyConf. Thanks for coming back from lunch to learn a little bit more about HAProxy at the network edge. By way of background, my name is Robbie Belson. I'm a developer advocate at AWS. And today we're going to talk about not just HAProxy on AWS, but HAProxy specifically on AWS edge computing services. So what we're going to talk about today is what does it mean for AWS to bring the cloud closer to end users as applications continue to evolve and modernize? And what were the challenges that were introduced? And most importantly, how did HAProxy not just function as a workload you can run at the edge, but an architectural pattern that solved real customer challenges today? Chris, you want to introduce yourself? Tell us a little bit more about what we're going to do today.
Yeah. So my name is Chris Smith, solution architect at AWS. I've been with the Wavelength project since it was announced at reInvent in 2019, helping companies really understand how to utilize edge and how to make it efficient for them. I'm a hybrid edge specialist, and I'm super excited to be here today to talk to you guys about exactly how we can actually help you and how some of the interesting things that we've been doing to bring HAProxy and edge together to solve some of those interesting problems that Robbie mentioned. So I'm going to turn it over to Robbie to kind of kick us off.
Maybe I'll start with a few questions. Raise your hand if you have a 5G phone or want a 5G phone, know something about 5G. Okay, great, a few hands. Now raise your hand if you saw an advertisement about 5G over the past, 48 hours. Yeah, almost all of you. As we're seeing, applications are evolving. The network is evolving. So the question then becomes, how does your application environment keep up or modernize alongside the underlying network itself? And as you think about whether it's an enterprise, a small development team, system integrators, they were all asking us the same questions. And they were saying, look, as our applications continue to evolve, as our users demand ever lower latency, ever higher bandwidth, as we start to introduce data residency requirements, how can the cloud meet our needs? But most importantly, how can the cloud do so in a way that continues to leverage that same pace of innovation, that allow you to leverage pay-as-you-go economics, that allow you to leverage the scale and the ability to deploy globally in minutes? How do you do that? And we often describe this as the cloud continuum, as you see here. Just a way to describe all the different ways that applications can evolve or span from the edge or from the device all the way to the cloud. Because you ask me, what's the edge? Well, it varies. I'd argue that your handheld device is an edge device. Most iPhones or some iPhones have GPUs. That should count. So should the cell towers you see outdoors. So should those local aggregation points of presence for a CDN. They all qualify as the edge, but they all serve discrete and different purposes. And so whether it's on-premises, whether it's metro centers, whether it's 5G networks, we're continuing to deliver the cloud closer to where our users need them. And that manifests itself in a number of different ways. If we jump to the next slide, as we think about our AWS regions today, or we go from right to left rather, there are dedicated IoT devices you might have in a disconnected environment. You may need compute in a disconnected environment. That's what we refer to as our AWS Snow family, or Snowball Edge is one such example. But there could be cases where you need to bring that compute actually farther away from the device so that it can serve a broader and more geographically diverse audience. That might be where AWS Local Zones comes in, where we bring familiar compute and storage services closer to metro centers and industrial centers. But it could also be a 5G use case. Same things, AR, VR, smart campus, autonomous vehicles, as Chris will talk more about later. You may want that highly localized, ultra-low latency compute, and that's where Wavelength comes in. So the point here being, whatever compute solution you're looking for, customers were starting to ask for how we can meet their needs, and these are the infrastructure services that we deliver today to help meet customers exactly where they are today. The question then becomes, Chris, as we think about edge computing, what are we going to talk about today? There's so many different choices. We can't possibly cover all of them today. What are we going to do?
Yep. So I'm going to talk about, I guess, kind of the center of the spectrum that Robbie just mentioned, the continuum, really where the wavelength zones and the local zones actually fit. So what is a wavelength zone? first of all. So Wavelength is a partnership between AWS and select wireless carriers across the globe. So we've got Verizon in the United States, we've got Vodafone here in Europe, KDDI in Japan, SK Telecom, South Korea, and Bell Canada. So those are partnerships that we have, and across the globe we have 28 wavelength zones for you to deploy your application into to actually make them edge enabled. So let's talk about what exactly is a wavelength zone when I say that. So if you look at this, right, moving from right to left, what we've actually done is we've taken AWS compute and storage and embedded it directly into the carrier's wireless network. What this does for you is it means that the round trip time for your application to go to compute is low. So you now have ultra low latency, but you also have improved security and improved resilience, because your data never goes into the internet. It always stays on the carrier network, and it has a very short path to travel. So we've kind of rounded this out with a high-speed circuit from the wavelength zone back to the AWS region, so that you have high-speed round-trip connectivity all the way through. And finally, one of the things that we've done is that we've actually exposed this in a way, and for those of you that understand AWS vernacular, as an availability zone. So an availability zone is a fault domain within AWS, and they've been around forever. So Wavelength just looks like another availability zone. What this means, it means that you can use the same processes and tools that you use today to deploy and manage your applications. Nothing has to change. It's the same overall paradigm, which really reduces the time it takes for you guys to deploy on edge. So one of the things I kind of want to talk through is, what kinds of use cases are we seeing today? What's going on at the edge, just to give you an idea. And I'm just going to go through a sample. There's no way I could cover them all. But some of the ones that are interesting, right, around connected venues that we were talking about. So accelerated access to venues, being able to make sure that people can get into those sports events very quickly. No one wants to wait in line to get into venues. Right, crowd management, real-time crowd management, understanding what the lines for concessions are, or for restrooms, or even like being able to take your mobile device and point it at your favorite athlete and get real-time stats on everything that they're doing at the time, personalized for you. These are some examples, but other examples are in like the healthcare field. So on medical, for example, connected ORs, where doctors can actually collaborate and train over longer distances, optimizing their time. We're even working with the ambulances and EMTs to be able to actually allow routing in real time of ambulances to the right facility based on real-time patient diagnosis to a facility that has the appropriate equipment and capacity for them, greatly increasing the outcome for the patient. Now you think about it, these things have real impact on people's lives today. So these are some of the things that we're working with. Maybe you guys have or have not bought into the whole metaverse thing, but AR and VR there's tons of use cases out there. Virtual, we've got digital twins for manufacturing to do predictive maintenance is a big one. We've got things like virtual dressing rooms for retail, for example. And even the pandemic has had an effect, because we've got CV use cases where we're monitoring for safety equipment for construction sites or masking or things like that. So all of these things are happening in real time and have impact on people's lives. The thing that all of them have in common, though, which I think is interesting, is they all require connections of hundreds or thousands of devices being ephemeral on the network, coming in and out for requiring high-performance connectivity standpoint. And then we are at HAProxyConf. So, Robbie, why don't you walk them through how HAProxy fits into all this?
Absolutely. And a great place to start, I think, is the origin story of HAProxy on AWS Edge Computing. So let's take the clock back to late 2019, early 2020. AWS Wavelength was fairly new. We were getting a ton of questions about, can I do this? Can I do that? One of the first questions we got was, can I load balance high volumes of traffic across a fleet of virtual machines? And the answer was absolutely. You had to build it yourself. Today, the application load balancer is generally available, but if you wanted layer 4 load balancing, same challenge applied. So we gave our friends at HAProxy a call, recognizing that we could try to build it ourselves, or we could collaborate with the HAProxy team directly and figure out not just can it work, but how can it work in the most performant way. And so we started with, I think we're done right here, in the following slide, where you'll see a very, very simple architecture. I wanted to showcase that if you can extend the cloud that you know and love today to a single edge zone. Let's just assume for a moment we're in the Northern Virginia, US East 1 region, and I want to extend it to my hometown in Washington, DC. Well, just create another subnet in the Washington, DC wavelength zone, create an active HAProxy Enterprise load balancer, and a target group. Create the config files, and you're good to go. So I'm done, right, Chris? We're done. We can go home now.
Not exactly. Right, so what's interesting about all the slides, the ones that I showed and the ones Robbie showed, is it shows everything in a very linear format, right? If you think about it, you've got the user equipment, the phones up on the right, you've got the edge in the middle, and then you've got regions. In reality, though, it's not at all like that. What we found is that every application looks more of a hub and spoke type application, where you've got the region as a hub, and then you've got these spokes, which are typically your edge compute coming up and down, like ephemerally, based on it. So how do you manage that? How do you deploy and manage that environment? So some of the lessons that we've learned and utilizing HAProxy has really been around like creating the right way to bring this together. So there's three things that we've learned on this as we go through. Now, you could deploy everything. You could deploy your application to all 28 zones simultaneously. You could keep everything up running 24/7. That would make things easy, but it's not super cost effective. And it certainly kind of breaks one of the rules of the cloud, which is elasticity. So being able to actually only pay for what you're using. So there is a better way, and there's three things that we've actually learned as we're going through here. The first being is that as you deploy to these edge locations, you need to be atomic. So you need to deploy the entire edge as your entire stack as one atomic unit. So the other piece of it is we recommend you using auto-scaling groups. And I don't know if you guys are familiar with AWS, but we have auto-scaling groups that does all the heavy lifting on deploying applications. And you can set your desired count of your auto-scaling group to any number you want. So you can set it to 0 and basically have nothing there. So you can actually use an auto-scaling group, and then as you need resources, you just increase your desired count. You call the AWS API, increase your desired count, and AWS will handle the heavy lift of deploying the entire application stack, HAProxy and the entire stack. Once that actually happens, though, as that starts coming up, we've got something called a lifecycle trigger that will trigger as everything comes up, and that's actually where the secret sauce is, because that's where you're going to call the data plane API for HAProxy, and then dynamically configure your HAProxy configuration. Now, it doesn't matter what automation tool you're going to use to do this. You can use Terraform, you can use Ansible, you can use CloudFormation, whatever makes sense for you. We don't care, but following these rules will actually make your edge-enabled application much, much easier. Right, so Robbie, why don't you take them through what you've done with Terraform on HAProxy?
And this is some real-time stuff, folks. We were doing this morning with the HAProxy team, continuing to refine the configuration files you see here. So this is just an example. You could do this in Terraform, CloudFormation, Ansible, your choice. But I'll tell you why I chose Terraform, and I think it's really nifty. On the left-hand side, what I'm basically saying is you're not going to know on day 0 where your end devices could be. So it's a guess. And that guess is you want to probably introduce all of the edge zones you could ever possibly entertain as part of your use case. For illustrative purposes, I picked 3. And under each of those objects have an availability zone ID, so where am I deploying to? How many of these nodes do I want? That's the node count. You can set that to 0, you can set that to 2 for active-active, up to you, side arrange, etc. So all of the metadata you need for each edge zone gets pulled in there on the left-hand side. On the right-hand side, to actually deploy HAProxy, what I'm basically saying is the desired capacity for that edge should be whatever I put in the config file. It may change later, but let's start there. And then Chris mentioned the lifecycle events. That's where a data plane API, and specifically this EC2 service discovery feature, is just awesome. Because all I have to do is add a few handy-dandy tags there. You see HAProxy Enterprise Edition service name, each key. What I'm basically saying is I'll have a config file for each edge, because disaster town happens if you now have a Boston load balancer proxying requests to a target group 1,000 miles away. You don't want that. So you want dedicated configuration manifests for each edge location. And in creating specific tags for each HAProxy service name, you can easily do that. And so even though I could end up creating, 10, 20, 30 HAProxy configuration files, it's 30 lines of code right here. And Terraform will automate essentially the for loop, as you see here on that first line, for each wavelength zone that I've described on the left-hand side, create those configuration manifests for me. And what's actually happening is that configuration manifest that's being generated is then applied as a bootstrap script to each of those load balancing nodes. So in 35, 40 lines of code across these 2 lines, I'm creating the core algorithm alongside data plane API, which I get out of the box to make this edge or multiple edge concurrency from a deployment perspective actually work. So let's keep going. I just want to show you what this looks like a little bit deeper. How do I generate those manifests I wasn't showing you? On the left-hand side, remember that each.key? You're seeing that again. So I'm borrowing that same idea, that same for loop. We're going to say, hey, I'm going to create a number of different manifest files, each of which will have different discrete service names, so that each config file is different. Of course, the difference in each file, there's the file name that is appended with a different city code, and there's a different availability zone. So we're making this really modular. We're making the developer experience super easy. And this is how we did it with Terraform. Of course, there are a number of ways. You might be saying, well, hey, Robbie, you forgot your AWS secret key or access key. Turns out, you don't need them. All you need is an IAM role that has the ability to list EC2 metadata, and you're good to go. And a huge shout out to Dario, Frank, and team for catching that. We want to make sure there's security best practices applied. You don't want secret keys in plain text, now do you, Chris?
No, absolutely not.
All right, let's keep going. Let's talk about service discovery, edge discovery. How do we do it? Let's jump to the next slide here, because there's a big problem we have. Congratulations, your entire edge environment is automated. But what if I told you these edge environments don't always play nice with DNS? How many times have you been on an airplane, about to take off, you're listening to music, the safety video comes on, and they say something like, the closest exit may be behind you. That applies. That actually really applies to north-south traffic. How do I get from point A, my device, to point B, the edge? Is it edge 1? Is it edge 2? Is it edge 17? DNS can't help you because it's often, in the case of the mobile edge environment, the way that determines the topological distance or latency has to do with things like IP anchors. You don't want to deal with that as a developer. Turns out our communication service provider partners, the likes of Verizon, created edge discovery services. Think of it as a basic service registry. It can register IPs, FQDNs. It'll take care of the undifferentiated heavy lifting associated with where should you go. But who's keeping that service registry up to date? I don't know how to do this. And I was completely stuck. We were working with Verizon. We needed a way to do this. Well, turns out HAProxy already solved it for me. How did they build the data plane API, the service discovery feature? Tags. So using the same model, by tagging things that should then be associated with that logical entity, the same very design of data plane API, I built another data plane API, which I call the Edge Discovery Service Data Plane API. What's it doing? 7 steps. Step 1, tag your nodes associated with a given service, just like you would for registering targets, the tag key and a tag value. Great. Event bridge. Event bridge is our serverless event bus. Anytime a virtual machine goes up, down, or sideways, you get a notification. Depending on the lifecycle event. Is it running? Is it terminating? Is it terminated? So based on those lifecycle events, we trigger an AWS Lambda function, a serverless function that says, hey, what just changed in my environment? And are those tags that I defined in step 1? Did something change that actually has those tags? Awesome. I'll go change my service registry with that information. And in doing so, that's how you solve the north-south traffic problem. So what does this mean for the HAProxy community in the case that this doesn't apply to you? This is like data plane inception, folks. We're using the data plane API for the east-west traffic to go from load balancer to target, but we're also using the data plane architecture to then register targets from a north-south traffic perspective. So data plane API becomes this all-encompassing architecture to make our lives that much easier. If we go to the next slide, I'll just briefly mention that we're still not done. You can do even more because it doesn't have to just be IPs. You could register just FQDNs. So myawesomeapplication.com or edge.com, you could prepend that with city codes, and they could turn out to be subdomains. So instead of registering specific IPs, you could register subdomains to the service registry and keep your DNS up to date with the latest IPs. Same workflow, additional step. That's that pink line there, Route 53 being AWS's DNS service. So lots of options here, but whether we're using this example with DNS or just straight up edge discovery, it's still that data plane API inception. Really grateful to the HAProxy team for having such a pattern that we could introduce. So back over to you, Chris. I think we're done, but we didn't really cover that scenario where, wait a minute, do I want 0 nodes, 2 nodes? Which edge zone should even be up? I don't want to pay for all of them at once. What do I do?
Yep. Yeah. So we've talked about a lot of things, right? I've talked about automating nodes, keeping things autonomous, using auto-scaling groups, making sure you parameterize everything. Robbie walked you through the edge discovery service, the DNS component. But the real key is how do we put all this together to actually create that application that I described earlier, which is you've got the hub and spoke where you have spokes that are ephemeral coming up and down. You need some orchestration layer to do that. And the nice thing about it is, if I've got this problem where I've got my mobile device and I'm moving around, my problem is I don't know what my closest edge device is. I need to figure that out in a way to do it. And I don't necessarily want to do all that processing on the phone itself or on the device because of power usage and processing, so I need a better way of doing it. So what we found is this is like another way of using HAProxy, not just using it as the front-end load balancer for your application, but actually using it as an API gateway to front-end that business logic that you're going to need to actually make your application dynamic. So it's a pretty cool solution. What we ended up doing was basically making the call to HAProxy. Behind that, we've got Lambda functions and business logic that actually do a few things. The first thing is it's going to go out and call the edge discovery service that Robbie just talked about and ask two questions. The first question is going to be, what's my closest absolute endpoint? Right? And that's my closest edge. It doesn't matter if my application is there or not. I just need to know what that is. And Edge Discovery Service will tell you. And then you're going to ask, second question is, what's my closest service endpoint? And that is, as Robbie mentioned, with the Edge Discovery Service, when you bring up your application, you register it with EDS to determine, so it knows that your application is running at that endpoint. So you're going to ask both those questions. You're then going to make a comparison, and if those things are equal, then you're done, right? You're going to the closest spot, you're fully deployed, that's good, right? You're probably going to want to log that for decommissioning purposes, but you're effectively finished with discovering your edge. If they're different, however, you have to ask yourself a next question. And that question is going to be, do I need to spin up a new node? Right? And that is where that's based on your application requirements, right? Certain applications, maybe are lightweight, you might want to spin things up, depending on heavy, how much traffic. These are all factors that you can take into account and write the business logic in to determine whether or not you need to spin up a new node. Assuming then that you do need to spin up a new node, we kind of use the application logic that I talked about earlier, that full automation stack. That's why I said it was so important that be atomic, because now, and parameterized, because now you can actually use your automation to spin up a new node, give it the details of the node. We're going to basically call the AWS API to increase the desired count on the auto-scaling group up to whatever resources that you need for the new node. And that lifecycle trigger that Robbie and I have been talking about, which is kind of key. You're going to then, call the data plane API to do all your HAProxy config. But now you're going to do a second thing too. You're also going to go register that node with EDS. So now the discovery service now knows about your new node, then it's up and down. So what's really cool about this is that with the data plane API that HAProxy has created, with the tools that we have at AWS, we really have a great cohesive story to really leverage the edge in a dynamic, effective way. And I think it's really exciting, some of the work that we're doing and some of the work that we're continuing to work on. Some of the futures that we're really looking at, right, is there are a couple things that are not supported on Wavelength or on our edge today. One is a web application firewall. And the other is API gateway. Neither of those are actually supported on the edge today. So using HAProxy to be able to actually start building out those services are something that we're actually looking at doing. As well as, if you remember that we talked about that cloud continuum, we were just talking about the middle, but Robbie also mentioned that we have disconnected devices, which is Snowball Edge, right? We want to open the aperture of what we're actually doing here and not just focus on the middle of that spectrum, but make it wider so that we're actually covering more things, increasing the number of use cases and things that we can support. There's a lot of use cases for disconnected environments, things like ships and cars, and military operations that we're actually looking to do. So super exciting stuff that we're doing here, and we definitely would love to talk to you guys about it as we move forward. So that's all I have. I hope you guys found this interesting. I know it was a lot of information in a relatively short period of time. But our contact information is up there. If you guys have questions, want to see any of the code, want to talk about use cases, we'd love to actually talk with you and kind of see what you're thinking and how we can actually leverage Edge and some of the things that you guys are doing today. Robbie, do you have anything else you want to add?
Just really appreciate the time. Thanks for sticking around and learning a little bit about the Edge. And you might be asking yourself, how does this apply to me? Whether you're looking to build a 5G application or simply satisfy data residency or lower latency requirements, try a local zone. We announced a number of local zones coming to Europe over in the future here. You can see a complete list on the AWS Global Infrastructure page. But try it out. We'd love to hear your feedback, and we look forward to seeing what you build. Thanks so much. I'll turn over to Dylan.
Great job, gentlemen. Look, we have time for probably one question. This came in from the online team. So this is related to, okay, so how should the HAProxy community be, what should the HAProxy community be doing to prepare for this mobile edge future? So if we think, what comes to my mind, food delivery, ride-sharing apps, Pokemon Go, augmented reality, self-driving cars. Specifically speaking to the HAProxy community, is there any, how can we prepare for this?
I'd say generally something we like to say at AWS is learn and be curious. I find the best way to get involved is just start building. I think one of the beauties of the edge is abstracting away the complexities of the network itself, particularly with wavelength. You don't have to know anything about how the 5G network operates. You just build on it. And so definitely encourage you to get involved. All the code we've been talking about here, we're going to hopefully release in the next few weeks. And so come build with us. Come help us make this data plane API implementation that much better. And look forward to seeing what you build.
Yep. I'll just add to that. I think that, I don't know how many of you guys use AWS, but certainly get an account, poke around. If you do use AWS, we've made it super easy to use the edge. So lots of ways to experiment. I'd also think about what kind of use cases that you can do, because there's interesting things about edge that I found is that one is, there's the existing use cases, the more mundane ones, like enhancing the real-time video streaming, point of sale type things that are super important. So depending on your industry and vertical, those types of things might be ineffective. But one of the things that we found is that edge and that ultra low latency opens up things that you didn't think were possible before. So you can start thinking about things, the art of the possible, things about things that maybe you hadn't considered before, where you might kind of poke around and do things. So again, I would love to talk to you. Since I've been doing this for the last couple of years, I've heard everything from herding sheep with drones to obviously pedestrian avoidance and cars. Lots of interesting use cases that I never even thought I would ever run up against. So certainly encourage you guys to think creatively and think outside the box.
Gentlemen, thank you so much. Once again, big round of applause for